All right, so let's look at another SAT type problems. All right, so we're gonna do one easy one and one really really tough one. So this easy one, which of the following is equivalent to 16 s to the fourth minus 4t squared? Well, I'm hoping that you guys notice that these things are a difference of squares. All right, and remember when that happens is you should be able to take the square root of both of them. Okay, so you should be able to take the square root of both of them. But even before that, what do you notice? All right. If you look at the answers kind of give you a little bit of a hint. You look at all those answers, you'll notice that there's something there. All right. What's our GCF? I can divide both of these by 4. All right. I can divide both of those by 4. Um, so I'm left with 4 s to the fourth minus t squared. All right. Now, talk about doing difference of squares again. All right. I can still do difference of squares there. Okay. So I can still take the square root of each one. And when we do difference of squares, there's this pattern here. All right. So the square root, the square root of 4s to the fourth is equal to 2s squared. So the pattern is going to be 2s squared, 2s squared. One's plus, one's minus. And then I have the square root of t squared, which is equal to t. And if you look, here's our answer. All right, 2s squared, 2s squared. So the answer is going to be C. Now, let's look at this second one. This one's a really, really tough one. Okay, this one's a tough one. Stick with me though. All right, we'll get through it. We'll get through this one. A car is traveling at x feet per second. So x feet per second. All right. Here is speed. All right. So we're talking about speed there. The driver sees a red light ahead, and after 1.5-second reaction time, here's time. The driver applies the brakes. All right. So speed and time. I'm hoping that you remember the formula. Distance is equal to rate times time. All right. So there's the distance. Rate is speed times time, and that's in seconds. All right. So we're going to be dealing with this formula a few times in this one exact problem. All right. So after the brake is applied, the car takes x over 24 seconds to stop. Again, here we have time. All right. During which time the average speed of the car is x over 2 feet per second. Again, we have speed. If the car travels 165 total feet from the time the driver saw the red light and to the time that it comes to a complete stop, which one of these equations? All right, so there's two things that are happening. All right, there's two things that are happening. Let me write some of the stuff down just so it's a little bit more organized here. All right, so there's two things that are happening. Is the time before braking. All right, so let's think about the distance before this driver even hits the brake. So before braking, and then we'll talk about the distance after braking. All right, or the distance while braking, I guess is better. Well, if I add those two together, that's going to give me 165 total feet. It's going to give me a distance. All right, so if you look at this, distance is equal to distance. All right, So let's organize. Holy cow, I don't know what that was, guys. Sorry. Let's do a little bit of organizing. So it told us that before braking, this car was going X feet per second. All right. So X feet per second, that's a speed. That's our rate. So X feet per second times, they gave us a time also. Remember they gave us a time up here? 1.5 seconds. All right. So 1.5 seconds. Now plus, if you look for while braking here. All right. So speed. Did they give us a speed while during braking? They sure did. Here was a speed while braking. All right. So speed while braking. So there was our rate, which was x over 2 times. Did they give us a time? Yes, they did. X over 24. All right. So they gave us a time also. All right. So all of this is going to equal 165 because we should agree. Speed times time is distance. All right, so let me erase that. Speed times time gives me distance. All right, so we're going to just do a little bit of algebra here. Well, x times 1.5, 1.5x, no big deal. Plus x over 2 times x over 4. How do we multiply fractions? We multiply straight across. So I have x squared over 2 times 24 is 48. And that's equal to 165. Well, if you look at the answer, it's equal to 0. And there's no fractions, correct? All right, so if you look at all the answers here, all the answers, they're all equal to 0. And there's no fractions at all. So we're going to do a little bit of algebra. First thing we're going to do is let's move that to the other side so that we can get it equal to 0. And let's move this to the front because x squared, we want this in standard form. All right. So a little bit of quick algebra. We have x squared over 48 plus 1.5x minus 165 is equal to 0. Or at least now we got it equal to 0. All right. Now, how do we get rid of fractions? Because that's the thing that most of you guys get stuck with. How do we get rid of fractions? We get rid of fractions by multiplying by the common denominator. So I'm going to multiply everything by 48. So what I do to one side, I have to do to the other. So I multiply by 48. And what happens here? Those 48s cancel. I'm left with x squared. Now I still have to distribute that 48 to 1.5. So 48 times 1.5 is 72x. And then 48 times 165, that's a big number. And then 0 times 48 is still 0. Well, if you look at it, our answer is going to be D, correct? Uh-oh. I want to cross it out. Wanted to highlight. All right. So our answer is D.